Now this definition will motivate a different kind of multiplication, a new kind of multiplication, which is the cross product. Right? So the cross product is going to give us a different way of defining all of this, a different way of multiplying. So if you have u and v are two vectors and theta is the angle between them, then the cross product of u and v is defined as u cross v. Right? It looks like an X, and it kind of is, but u cross v, where the magnitude of u cross v is what we just showed, which is the torque. Get it? So there's the torque right there. And the direction, well, torque is just one physics application of it, but it drives it. And the direction of u cross v is perpendicular to u and b as follows, the right-hand rule. So if you put your wrist at the origin, fingers along u curled towards v, your thumb points in the direction of u cross v, what I was just showing you with my wrench. Obviously, a very important definition because this has a very important physics application, i.e. torque. So notice that the cross product of two vectors is another vector, but it's a vector in 3 dimensions. So we're able to take something with 2 dimensions, which is just, well, I mean, more roughly 2 dimensions, which is the wrench and the bolt, right? So you have your vector, which is your radius, and your vector, which is your force, and you're able to cross those and get a 3rd dimension, i.e. the direction that your thumb is pointing on your right hand. Cross products are not commutative. They are not the same thing. So you can't just do u cross v equals v cross u. In fact, u cross v is negative v cross u. Using that definition, it is generally difficult to calculate the cross product unless the angle theta is given, and even then only the magnitude can be determined. There are a few special cases that we can manage, however, so we will do that. So let's start with the first one. We have a u and we have a v, so we want to find u cross v. Now just take a note of these two right here. Interesting, huh? Okay, so notice that v is equal to 5 times u, right? It's a scalar multiple. So that means that u is parallel to v. And that means that the angle between them, theta, would be a big fat 0 degrees or 0 radians, doesn't matter, right? Interesting. So if we use the formula up above, u cross v, the magnitude of it, I should say, is equal to the magnitude of u times the magnitude of v times the sine of theta. But we just determined that theta is equal to 0. So it doesn't actually matter what these are. If this is the magnitude of u, the magnitude of v, I know that this part right over here is 0 because the sine of 0 is 0. It's not 0 degrees, that's just 0. Right? Here, let me make a note. Sine of 0 degrees equals 0. And therefore, I know that the magnitude of u cross v is equal to 0. And that would mean that u cross v, which was actually what was being looked for. I shouldn't have boxed that. That wasn't the answer. The magnitude of u cross v is 0. Therefore, u cross v is equal to the 0 vector. Which makes a certain kind of sense. I mean, think about it in terms of physics. If u and v are the same, that means that the radius and the force are actually together. So instead of twisting on my wrench, I'd be pushing it, which wouldn't do anything to the bolt at all. It's not going to help anything. So that's no good. So it's the 0 vector because you're not twisting at all. You have no twisting power because you're not trying to twist, because you have your u and your v being parallel to each other. You're actually shoving onto the tip of the wrench. You're pushing it, which doesn't do you any good. So therefore, the cross product of parallel vectors, we have just learned, will always be the 0 vector. It's not 0 itself, it's a 0 vector because a cross product is a vector. It just so happens in this case it's the 0 vector. All right, what about the other coordinate vectors? So, and if you look up the right-hand rule, this might be what you see when you look for it on like Wikipedia or online. You'll see something with people doing kind of finger motions for the three different coordinates axes. So I, of course, is this direction. I'm gonna pretend that three little hash marks makes one. So that's I. Otherwise, it's too small of a graph. And then J is right here. Sometimes they'll put little carrots on them. Sometimes they'll put they'll bold them. Sometimes they'll put arrows on them. It doesn't really matter. Everybody knows what we mean. So we mean I, J, and K. Okay, so if I take I with J, right? So this is the right-hand rule. So if you take I with J and you cross them, you'll have K, and you'll stick straight up in the air. So this would be K. If you go J with I, you start your hand at J, rotate it to I, and that's going to be negative K. Your thumb's going to be stuck down into the paper. If you have J crossed with K, so if I take J, I take my wrist at the origin, right, and I cross it with K, so that I'm rotating this way, then I'm going to have I. I'm going to be sticking out in the I direction. Very interesting. And then if I have K crossed with J, so kind of reverse it, I'd be sticking my thumb back into the back direction, so that's negative I. And then I crossed with K. So just to reiterate, what I'm doing is the right-hand rule, right? So you put your wrist at the origin, your fingers are along you and curled towards V. So I put my wrist at the origin, I have my fingers on I and they curl towards K. And you can see on I curling towards K, I'm sticking my thumb out in the negative J direction. So that's negative J. And if I go the other way, which I can't really do, but if I had my wrist here at K and I curled towards I, then it would be sticking off in the J direction. So that's J. That's the right-hand rule, and that's how it works. All right, now you'll notice there's a little bit of a pattern here if you pick up on three of them. This one, and then this one, and then this one. So look, if I have I, and I cross it with J, I'm going to get K. If I take J and cross it with K, I'm going to get I. And if I take K and cross it with I, I'm going to get J. There's a pattern to this, right, that rotates this way amongst these three. So I cross with J, I cross with J leads me to K. These two lead to that one. K cross with I leads to J. J cross with K leads to I. That's those three pink ones working out together. That's the positive orientation direction, so it'll flip around like that. And you can tell there's obviously a negative one kind of working as well.